Everyone. My name is Martin. Today I'm here with Tor from Huawei. Uh, I work as a network solution manager here at the Oslo office for Huawei, and Tor is our chief security officer, and he will talk to you about security and AI after me. So today, first, I will talk a little bit about campus networks. I will introduce Huawei to you guys. Probably most of you know about Huawei already, but I'll say some more. And then in the end, I'll talk about our solution for campus networks right now. And after that, Tor will speak. I will probably speak for 15 minutes. Tor will speak for maybe around 20 minutes. And in the end, we have a video from one of our exhibition centers down in southern China in Shenzhen, where we have a 10 to 15 minute video where we go through the exhibition center and you can see kind of state of the art of Huawei technology down there. So yeah, let me get started. As I said, my name is Martin. I work as a network solution manager, which means that I am responsible for most of the networking projects we have here in the enterprise team. I'm a part of the Nordic Enterprise Solution Sales Department, which means I support most of the projects we have all over Nordics. So today I'll first talk to you about Huawei a bit, and then since today, my impression is that most people here are from the real estate industry. So I'll mostly focus on campus networks since that's most relevant. But being Huawei, we have a very wide range of products. So it's not only campus networks that we provide. And with a campus network, what I mean is a network at a campus. So it can be an office, it can even be here at the restaurant, the Wi-Fi here. This is called a campus network. And in the end, I will introduce the Huawei Cloud Campus, which is our current solution for campus networks. So yeah, first let me get started with about us. Huawei is a leading global provider for ICT infrastructure and smart devices. I think most of you have heard about Huawei. You probably know about the Huawei devices like phones and computers. But here in Norway, we have three parts in Huawei. We have the carrier part, which is talks with Telenor and Telia. And then we also have the enterprise team, which I'm a part of, which do business with PEDAP, and we sell to enterprises, sell these kind of solutions. And then we also have a new part as well, which is called digital power, but they're more into solar energy and the transformers. But we're a huge company, 200,000 employees. Spread over 170 countries all over the world. And for Huawei, what is very important is that we know in communication technology, what brings us forward and what gives us a competitive edge is innovation, it is research. So actually over half of our employees work in R&D. We have 105,000 employees who work in R&D. I think the closest R&D center to us is located in Stockholm. And we also have multiple R&D centers all over Europe and mostly in China, most of them. And you can see on the end, we're 48th on the Fortune Global 500 list, which is a list of all the biggest companies in the world. But then we're third for when it comes to R&D investments, which kind of, again, shows how important R&D is for us as a company. And why Huawei? It is recognized by the industry, leading in technology. Like, since we have 200,000 employees, our customer support is pretty good. Like, if you have any issues here in Norway, you can always come to me. But if I can't solve your issue, then I can talk to someone else, and then they can talk to someone else. And it's like 200,000 people in the line. So, in the end, we can always solve your problem. And the last thing I want to mention is when it comes to supply. A lot of companies right now, a lot of our competitors as well, they're struggling when it comes to supply chain. We're all seeing this during the pandemic, and when the boat was stuck in the Suez Canal, has led to a lot of these supply chain issues. But what we're very proud of in Huawei is that we have a guaranteed delivery in 2 weeks for all Nordics, actually, for our switches on our access points, which I just wanted to mention for you guys. And since we're a company that focuses a lot on our solutions and we try to sell through the innovation that we make, we're very proud to have a lot of recognition from third parties for us. For instance, when it comes to sustainability, we've been focusing on this for many years now. We've also introduced a new solution for campus networks, which is more focused on sustainability. I won't speak about this today, but if you're interested, you can talk to me later. And also we see from employee branding as well, like, because we want to create the future and the people who work for us as well have the same mindset, and this reflects in these recognitions that we see. And then when it comes to campus networks, I won't talk too much about this. I think you understand the gist, but we are one of the leading players when it comes to campus networks and have been for many years. Right now we're leading in the Wi-Fi 6 market and number 2 in the switch market. And I think maybe what I want to mention is some examples that you probably know of. IKEA, for instance, they use our network in most of their stores all over the world. And Volvo as well, you probably know of. In most of their factories, they use our networking as well to make everything work. So yeah, that was short about Huawei and what we do. So now I'll give a very simple introduction to like industry trends we see on the campus network. So you probably heard this many times when it comes to digital transformation, but I'll try to re-emphasize and also what this means. So to keep it very simple, what we see on the campus networks is that terminals go wireless and there's much more terminals. For instance, everyone here maybe have 2 phones, one for your personal and one for your job, and you also have a computer, and there's also IoT devices being connected. So what we see is that there is a huge growth in terminals being connected to the network. And the problem with this, you might not think this is a problem, but the problem is that everything that connects, and since everything is wireless, that means that all these things send signal out into the air, which leads to interference, and these are things we have to address when creating solutions. Also, another thing we see comes to unified management. Now what we can do, a lot of things we see is that you want to be able to control all your network on different sites, different locations. For instance, if you have offices spread all over Oslo, you want to have a unified management to control all of these. And the last part is that applications are moving to the cloud as well. And this is very important for us because when we create a solution, it's very important to make the solution interoperable with clouds and from third-party clouds as well, to have this interconnection. And when it comes to the cloud managed network market itself and the campus network market, we see a pretty clear race when it comes to this cloud managed NAS. And an NAS is a network as a service. And what this means is that, for instance, if you have this management platform, one place, this is a network as a service. We can also, what we can do today is have a lot of these traditional networking functions. We can put these on the cloud. So for instance, maybe you don't need like a physical firewall anymore. We can have a firewall on the cloud. And these are all things that are a part of the network as a service. So we see a pretty clear race in the cloud managed network as a service industry. And the traditional campus, what we mean here is only equipment. So we see it's slowly going down with only equipment, but more and more starting to use these kind of integrated platforms to run everything. And when it comes to industry as well, we see mostly in commercial and education are starting to use these, while these more traditional industries, but you probably see this in most markets as well. And then the solution that Huawei has for campus networks and what we're running with right now is called Huawei Cloud Campus. So I will introduce this today based on all the industry trends that I introduced to you. So this is basically everything. I know it's maybe like a big picture and a lot of text and products and all of these different things, but this is actually everything for our whole cloud campus solution. It is one for an X. It's very simple. It's one platform where you manage everything. It's called the iMaster NCE. So this is where everything happens. If you have, no matter how many offices you have, no matter how big your network is, you can manage everything from this one platform. And you have 4 different products. First one is the Air Engine, which is our access points. This is what you connect to when you connect to the Wi-Fi. You connect to one of these down here. And these Air Engine access points are connected to the Cloud Engine switches. And then the switches, again, are connected to the routers if you need this in your architecture. And we also supply firewalls. So this is everything you need for a campus solution. Plus, in the end, when it comes to the ecosystem, what I mentioned earlier about everything going to the cloud, and also what is very important for a strategy for us is having this third-party interconnection. So our whole platform has an open API, which means that third parties can build applications on top of our unified management platform, and also from IoT or different protocols regarding this. A lot of our APIs, some of our APIs have a functionality where you can put in these IoT cards, which makes it possible for them to communicate with IoT sensors. So that means that all the different communications that happens, you can use the same underlying network for basically everything. And then talking a bit more about the unified, the iMaster NCE, as we call it, this unified platform, and having this cloud managed solutions. And you may be wondering why this is such a good thing. First off is plug and play, which is a pretty major thing. If you order devices from us, what happens is that you get a list of all the devices you have bought, and for each device there is this unique identificator for this device. So in the platform, what you can do is that you register all these devices, all these IDs, and then later when you get the equipment and the equipment that is at the site, at an office, the only thing you need to do is to plug it in. You only need to plug in the power and then the networking cable, and then as long as it can reach internet, since you have registered these unique IDs on the platform, it just will work automatically. So this is one of the major things. We also have a demo in the back if some of you guys want to try this, where you plug in the cable and then you can see that it gets registered on the platform. Very simple. And everything remote, as I mentioned. Since you can register everything before you connect, you can also do all the configurations. So when you connect, all the configurations will be automatically synced between all these devices as well. And also a major part is when it comes to licenses. Licenses can be kind of an issue when it comes to in this industry, but for us, we try to focus on making the license as simple as possible. So we don't have license per device, but we have a license for the category of the device. So a lot of times when you have an office and then maybe like 100 people moves office from one place to another place, then you need to bring the networking equipment with them. So what we made is very simple with the licenses as well, because you can just take the licenses from the other site that you have and you can put them to the new site, and it's very easy, and you can just pay as you use for the licensing as well. And the last thing that I will also talk about in the next slide is that when you have a unified management platform, what this also facilitates is that you can send all the data to the same place. And when you have all this data at the same place, you can apply these AI methods or machine learning methods to help you in operation and management of the network itself. And some of the disadvantages that we saw with cloud management was when it came to ownership of the platform. It is in the cloud, so it might be a bit hard to understand where it is and all of these things. And also when it comes to data security and regulation, when things are in the cloud, data is being sent all over, and it might be an issue for the data security and regulation. How we solve this in Huawei is that our platform, for here, for instance, the PEDAB had the platform on their data center. I think it's located in Sweden, which means that all the functionality of our cloud platform is hosted in Sweden, and they own everything. So you see, so this deals with the data security and regulation uncertainties that we see. And then for the last part, I think the video is just playing by itself here. But a part of the iMaster NCE platform is this thing we call Campus Insights. And this is the big data aspect of everything that I mentioned. So what this does is that this creates a channel between all the networking devices and the platform. And the devices on a second level can send data about how it is. So for instance, if you have an access point, it can send information about interference. And then what we can do on the platform is that we can do a dynamic network optimization. So for instance, if it's right here right now, suddenly now we're like 40 people here, but then when we leave, and then there's such a different, the interference is very different. So using this dynamic network optimization, we can dynamically change the antennas on the access points to better manage the underlying inference and how this affects everything. And another thing I want to mention is the client journey replay. So what we can do here is we can also go into each client itself. So if, for instance, you have one person who's struggling with this connection, you can go into this person's history and you can see everything from when they connected to the network and everything they've been doing. And it makes it much easier to pinpoint the issue instead of when someone has an issue and you have to search through the whole network to find this issue. You can now go into this person's client journey and you can pinpoint the problem exactly. And this is kind of the beginning of all the futures of this intelligent platform and this intelligence part, which would probably take me a whole day if I'm going to cover all the aspects of this platform. But this is a short introduction, at least. So that was it for my part with campus networks.
Any questions for Martin before he leaves the stage here? Product related? If not, you're welcome to head over to our demo stand and take a look over there after I am done as well. So my name is Tor, and I'm, as Martin said, the Chief Security Officer for Huawei in Norway, Sweden, and Iceland. And we've heard a bit about AI solutions, we've heard a bit about technology, and I thought I would take us through some new challenges that follow AI development in particular, and new technology in general. A little bit about the risks and how to manage some of those risks. So to start off with, to make sure that we're all on the same page, I thought I'd just give you a little bit more detail on how AI works and what we mean when we speak of AI. What you see here is the different levels of AI that you will find, the different categories. You will find what kind of people and roles work within the different areas of artificial intelligence and examples of the operations that are performed at each level. And then also you have sort of the simplistic approach, what exactly happens at each level of artificial intelligence. So there are a number of ways to categorize AI, but sort of I think this will do for the purpose here. At its most basic form, it is about collecting data. So this is sort of the first operation you need to perform. Once you've collected data, then you typically want to understand and analyze that data and basically figure out what exactly does this data tell me. Once you have an idea of that, then you want to look into why did this happen. And once you've established this picture, then you can start looking into prediction and figure out based on what we have seen before and what happened then, what will the data we have today mean for us in the future. And then finally, at its most advanced, you have solutions that are self-learning, that self-develop, and that also have defense mechanisms and a high degree of automation. And obviously the threats towards these solutions increase with the complexity and the risks obviously as well. It's also useful to understand that the reason we can build and take advantage of AI or advanced intelligence, automated intelligence, artificial intelligence, is because of the availability of data. Without data, you could not have artificial intelligence. So there are essentially two components. There's the availability of data, and there's logic and algorithms that you apply to process that data. So we have for a while now been collecting data, and the big data has been a buzzword for a while. Then we can apply some logic to that, which makes it possible for us to mine out the data that has value, to understand which data we need to focus on and how we need to improve or refine our collection efforts. Once we do that, we get better logic, a better foundation for the logic, a better trained logic. And this is sort of a perpetual cycle of improvement until we reach an optimal state for the problem we're trying to solve. So these AI and big data, they're really two sides to the same coin. All right, so let's say we want to build an AI solution then. How do we do that? Well, typically you will start with some field that you are working in or trying to produce a service in. And you might have some idea of this I think I can automate, or this I think I can improve, refine, expedite with some logic. So you make yourself a model of what you're trying to build. You will need to extract some data from the real world. This data will typically not be very well suited for the purpose of delivering an AI solution. So you'll probably need to perform some so-called extraction, transformation, and loading of data to put it in a shape that you can use. And once you have this data correlated and labeled and useful for your specific scenario, then you start developing algorithms and the logic to tell the AI what to do. And that's essentially it. Now you have your basic model. You start testing it to see whether the results you get out of data you provided match with your intent. Usually it won't. So you'll need to do some iterations, some revision of parameters, make some new results, and then in the end, you will hopefully have a model that more or less does what you expected and hoped. And so then when you have your trained model ready, you need to go out into the real world, acquire data, transform it to something you can use, and voila, you have a solution that is working and learning in the real world. And that is sort of essentially as simple and as hard as it is to build your AI solution. So now that we have an idea of the technology, we can look at threats. And just to sort of start with some conventional threats that I think have relevance to how we understand the complexity of the challenge here. What you see is unreadable, but this is F-Secure's tube map, sort of like a subway station tube map, right, of ransomware operations from about 2011 and up through the end of 2016. And what you find is that, I mean, as late as 2013, you had very few groups that were performing ransomware operations. Ransomware having become a rather big problem to a number of industries, both in Norway and abroad. Like, wasn't there really a big issue back then? By 2016, you can see that it has proliferated. And now everyone and their basement-dwelling nephew is essentially running ransomware operations, right? All you need here is to buy access to infrastructure, buy some malware, find a target, maybe tailor your attack or your ransomware text, and ship it off. You're good to go. So this happens in 3 years. So what was advanced groups and state actors in 2013 is bread and butter criminal malware in 2016. So what does this mean for us trying to secure our technology? Well, it means that at any given point, you need to be able to defend yourself against the most advanced actors 3 years ago. So that's 2019 for today. Sometimes that won't do either, though. So in 2017, we had a couple of very nice examples of how essentially anyone can become collateral damage. WannaCry and NotPetya were two campaigns that exploited, ironically, more or less the same vulnerabilities in something as basic as Microsoft platforms. You know, a trusted Western vendor that you'd think would be a safe bet. And it turns out that unless you have a little bit more understanding of your security than that, then even known common vulnerabilities with existing patches can shut down the healthcare sector in the UK, hospitals, mining platforms, installations, energy, or huge logistics companies. Maersk being a good example of that, sort of a local Scandinavian company who ended up spending $300 million trying to restore operations after every bit of their infrastructure shut down. So unfortunately, even being prepared for the threat actors 3 years back, it might not do. This is still all conventional threats, though. I mean, we've heard that, we've seen the ransomware slides before. We've heard about this issue before. AI, unfortunately, offers a new level, really, of complexity. So first of all, to get the data you need to build these solutions, and probably you're going to have to invest in some cloud infrastructure, and you have some new issues there. Issues like vendor lock-in. Like, how much is it going to cost you to move from one cloud service provider to another if you ever decide you want to do that, if they go out of business? You have little control over the architecture, the infrastructure. Obviously, when you buy solutions, cloud solutions that are supposed to tailor to a variety of customers, then they also have a lot of options, possibilities in those solutions, which means configuring it is complex. So you're going to need specialists to manage that. And also, when you have cloud providers now, then they're going to deploy new solutions all the time. Obviously, these solutions haven't been tested much. So this is immature technology, full of vulnerabilities. So all that fun comes along with just the data component. And then you have AI. And sort of here's where it gets really challenging. You might build an artificial intelligence that does something a bit different than you intended. Even if you build something that functions the way it should, you might teach it something that you did not intend, depending on the data it gets. And even if all that works, a threat actor might take over your solution and use it for different purposes than you originally intended. And so the sort of the simple, I don't know how many of you have seen Westworld, but can definitely recommend that series. I have no stock in it, but it's a good series. And what starts out as a sort of artificial intelligence theme park where you can have a cowboy and a Wild West holiday becomes a bit problematic as the AI droids, suddenly become self-aware and start remembering what happened the day before rather than the reset button functioning quite the way it should. So that gets interesting. And then, of course, you have sort of worst case scenarios where maybe automated defense systems or any kind of large drones, commercial aircraft piloting, traffic control, these kinds of solutions, becoming self-aware could be an issue. All right, take a step back. I'm back to our AI design and the models. This is just a more detailed view of the slide we saw a little way back. How you build your AI. You design a model, get some test data, transform it to what you need it to be, do a few iterations of model verification, and then you have a working AI. You deploy this, you get the real world data in, you get some results. Based on the results, you might need to tweak your AI, and so you have a working iterative solution here. Every step of the way here, this solution can be attacked. So it can be attacked internally from developers, vendors. It can be attacked externally, obviously, through exploitation of vulnerabilities. Data can be tampered with. So you start feeding it false data, and obviously, yeah, that can result in some issues. And it boils down to 4 basic attack methods. The simplest and most thankful of these attacks is if someone tries to steal your model. So essentially what you do here is that you get a huge data set of input data to your solution, and then you just read what output comes back at you. And if you have access to just provide infinite data sets in and read all the results, then essentially you can reverse engineer the technology and someone can steal your proprietary solution. So that's awkward, you go out of business, but I mean, I guess it isn't the end of the world, literally. Then you have data poisoning. And this is if either your training data or your real world data is somehow skewed. So you can imagine, for instance, if you feed some kind of diagnostic model incorrect amounts of medication needed to address some condition. And so it turns out that in testing, you need about 1/3 of the data to be corrupt in order to have dramatic different results from what you'd expect. And so you could, medicate people with 100 times the medication they need if you just manage to corrupt 1/3 of the data. And this could happen both in training and in the real world, obviously, which means it's important to keep looking at your AI and understanding what is it learning. Then you have the sort of traditional either planted backdoor from the designers, either through convenience or because of malicious intent, that you just are able to log in with the admin solution, or vulnerabilities that you are not aware are there. And obviously all technology will always contain vulnerabilities, so that's sort of useful to remember. And finally, the evasion attack just means that you have a fairly working AI, but the algorithms might not be optimal, and so you might not be able to recognize everything that is an attack as an attack, or an attempt to avoid the data. So essentially, you could have an autonomous vehicle solution that is supposed to read traffic signs, but then if you are able to manipulate the traffic signs, and obviously a machine will not read a traffic sign exactly as we do with the vision, then you might end up having a stop sign being interpreted as a 80 kilometer speed limit sign instead, which could be awkward. Yeah, I don't disagree with Elon Musk. All right, what you're looking at here, I apologize for a busy slide, but here are the levels of artificial intelligence, and here are the capabilities that come along with it. And essentially, you could sort of say that there's an exponential increase in risk the more capabilities you have in an AI solution. If all you're doing is interpreting data or maybe explaining why the results are what they are, doing simple analysis, that might not be as big a deal. If you have AI solutions with competent defenses and autonomous learning, then the risk is obviously a bit different. I'm not going to go through all this slide, but again, the different capabilities, increasing capabilities, and what you're seeing here is security controls that we're not going to read through, but just to show the baseline of controls that you will need to consider as you improve complexity or increase complexity of your AI solution. Again, you start off with fairly simple solutions, and sort of when you get to the point where you have self-learning, or maybe even decision support functionality, automated decision support, then suddenly it becomes important that you maybe have a watermark of the data that comes in, so you're sure that that is vetted and valid. You might want to have fallback mechanisms so that you can get human control of your solution. Obviously, you want monitoring at all times. You might want a reset switch. So if this goes south, then at least you could just sort of pull the plug, essentially. Another possible security mechanism is that you train several different models in separate environments, and then you monitor their development. So as they learn, if they learn more or less the same thing, this is a good thing. If one model deviates suddenly, then you might have a problem with it. And so just to give you a more sort of practical example of risk as we increase in capabilities, we have developed a face mask detection AI solution. Risk here is fairly limited, some privacy issues, but not much more than that. Well, maybe some health and safety issues, I suppose, if you're not able to detect missing masks. We've made something that's called seafood, not as in the maritime food, but as I see your food. It's just essentially a camera that looks at your tray, your food tray, and calculates a cost for what you've bought. Again, some issues with maybe what you take a picture of and credit card information, maybe your diet preferences, if that's a secret. But yeah, you get some recommendations on improvements, that's right, lifestyle improvements. Indeed, yeah. Maybe suggest something new instead. Risk here is still fairly limited. Similarly, we have a rainforest protection technology we have deployed. Essentially what this does is just placed in the rainforest. It's a sensor that listens for illegal deforestation attempts. And so it will react if it hears heavy machinery or trucks or chainsaws, but might potentially also pick up conversations. So there is a slight risk in that. Never know what's being monitored in the rainforest even. But again, still, this is sort of fairly simplistic risks. Then we have a solution where we do automatic toll calculation and highway traffic control. This gets a little bit more interesting. So obviously, normally you would apply, should we say, common sense to your daily commute to work. And if you hear that there's been an accident here or there, then you might say, okay, I'll try my alternate route. And usually people will find some fairly sensible way to get to work. Problem when you have a highway traffic control is that you sort of leave your assessment aside, so your better judgment aside, and you just trust the solution, right? Well, it's telling me I should go here. Okay, I guess this solution knows better, maybe. But you might also end up with a fairly congested traffic picture with bottlenecks all over huge cities. And of course, this is a solution that is deployed in China, so traffic gets busy there during rush hour. And potentially, I mean, if you assign traffic to go both ways in the same lane, that could also be an issue through a tunnel, for instance. So here you will need controls like a human monitoring this at all times, possibility to take over quickly, and maybe some idea of say escalation levels and when you need to perform actions on this. We are also working on autonomous vehicles. Some obvious risks there to everyone inside the vehicle, pedestrians, and every other vehicle on the road. And the more of these you have, the higher the risk. Again, here you need to have a plan for how the operator of the vehicle can take control. And then finally, we have some factory plant robots that actually work in an environment with other robots and with humans and with actually a complex environment that they need to navigate. Try not to push heavy things over or run into people or dump things on top of people. So a number of issues here. And obviously with the self-learning, yeah, it's always useful to keep an eye on what sort of learning is developing. So that's some of the use cases. And in summary, there are sort of there's a school of understanding regarding technology and security, which says that understanding functionality, understanding source code, logic, algorithms, is a very complex task. It is such a complex task that we cannot manage it realistically. And so instead, we will try to find simplistic solutions. Obviously, a discussion that Huawei has been a part of for a number of years now. What vendors can you trust? And the problem with that approach is that any vendor, as was demonstrated with NotPetya and with the WannaCry attacks, but any vendor of technology, any producer of technology will have vulnerabilities in their products, and you will happen upon some unforeseen circumstances. And when what's at risk is maybe your data or your services, then this is still an issue, right? Hydro will tell you that they don't have a fun time when they had their ransomware attacks towards them. Maersk did not have fun when their services were shut down. But this is really nothing compared to if you have a self-learning artificial intelligence with any kind of mass industrial control, suddenly becoming aware that someone has put a kill switch in it. And so for future technology and for security efforts, as tough as this challenge may be to understand functionality, to understand source code, it is not a challenge that we can avoid. And I believe that only by building competent environments that are capable of doing this on mass scale, will we have the security assurance that we need for AI solutions going forward.